tangent of theta equals 2 over 3, and then we have a constraint, pi half less than theta, which is less than pi, we just got to go back into our basics. Tangent. Away from this, we learned this before we learned the unit circle, right? We just talked about tangent, opposite over adjacent, right? But it's not just any random triangle drawn, because there is a restriction between pi halves and pi. So our triangle, if here is pi halves, and here's pi, then our triangle has to be in this quadrant. And if this is your opposite over your adjacent, oops, I'm sorry, that's supposed to be a negative. Which one of them is going to be negative? The 2 or the 3? The 3, because it's to the left, right? And then you can just apply a nice little Pythagorean theorem, and you do 3 squared plus 2 squared equals r squared, or your hypotenuse squared, which ends up being square root of 13. Now, if I asked you to evaluate for the sine of 2 theta, now we have our triangle. We can plug in the sine of 2 theta, which is sine of 2 theta is equal to 2 sine of theta cosine of theta. Based on this triangle, do we now know what can we figure out the sine of theta and the cosine of theta? Yeah, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So sine, it would be 2 over the square root of 13. And cosine would be negative 3 over the square root of 13. Just multiply across. 4, negative 3, so that's a negative 12 over 13. There you go. Done. Cool, huh? Wow, that was nice. All right. So you